Okay, this is the first quick tour of the battery management system I've managed to design and construct. Everything seems to be going okay so far. Obviously lots of minor bugs in the software need to be sorted out, slight display issues. Here a quick tour. Here we can see there's 5 cells made up with 5 slaves currently on charge. These are digital slaves. They're communicating with the master board using simple serial protocol 8N1 at 1200 baud. Now if we look at the tops of the cells, look at the slaves, you'll be able to see the LEDs flashing in sequence. Means the master's communicating with that slave. Just zoom in slightly, I don't know how much zoom I'll be able to do. You can see the current sensor there in the bottom left. It's an Allegro Hall effect device which provides a 0 to 5 volt calibrated output. On the slave boards themselves we have the 08M pickaxe pick and a 250 milliamp load resistor, all are opto-isolated from each other. And just going over to the master, see I'm currently using one of these little dashboard screens, and this is another pickaxe 28X1 on the master board with a couple of other chips, a pickaxe 08M as a watchdog and an SV2000 which is a video IC. It basically produces a RCA compatible video output from a serial data input. So that's a very easy way of getting the information on the screen, you can see there. The master's got a shed load of outputs and you can see it's calculating the pack voltage at the moment. It thinks it's about 16.9 volts. If we look at the multimeter, that's actually reading 16.92. The accuracy I was hoping for was within about 50 millivolts, and all testing up to date seems to think accuracy is about within 40 millivolts across the pack. So that's I'm pretty pleased with that. A lot of buttons and wires going into the master. Obviously they're all ad hoc wired at present. Number go to switches, the master reset and A and B dashboard buttons. Number of LEDs are on at the moment. This is the first time that the BMS is being allowed to manage the charge, and it's actually controlling the charger by a simple on and off relay. Go over to the charger. This is the laboratory power supply, and it's charging at about 3.5 amps, and the power supply is independently set to cut off when the pack voltage reaches 18 volts. That's just another extra level of protection. In use the power supply will be off board, and it'll be a simple plug and socket, and the mains power input to the charger will be controlled by a simple onboard relay. I've got a dummy load here as well, which I was using earlier on to drain the cells down a bit. That could provide a dummy load for banks of about 5 cells up to a maximum of 100 amps. When I was testing at 100 amps I was getting a slight error, and the display wasn't actually working correctly, and I've located that. It's a integer division error, and I need to force the display to display leading zeros. So I was slightly worried that it was actually calculating and getting the wrong voltage, but it wasn't. It was getting the right voltage but displaying it incorrectly. So that's one of the minor software bugs to be sorted out.